Welcome everyone to this semester, the second talk in this semester's WestGrid seminar series. My name is Brian Corrie, and I'm the Visualization Coordinator for WestGrid, and I'm located here at Simon Fraser University. I'm going to be talking today about visualization in WestGrid and using the visualization infrastructure and support that WestGrid provides. It's going to be a pretty high-level introduction to the various things that you can do, and hopefully it'll open some doors to helping you more effectively visualize your data and things like that. So I'm going to talk for about probably 25 minutes to a half an hour. We have the rooms booked for another half an hour after the fact. So there should be WestGrid representatives at each of your institutions. So please feel free to talk to them after the fact and or ask me questions after the fact as well. So we'll leave the mics open probably for 10 or 15 minutes for kind of general questions, and then we'll probably break off into the individual institutions, and you can talk to your local site representatives from WestGrid. All right. So the way this will work, basically, for those of you who haven't attended one of these, if you have a question, just kind of raise your hand at your individual site, and somebody will turn on a microphone at your site, and you can interrupt me. If you have a burning question, please feel free to interrupt. But it might be easier if we wait to the very end before you ask questions. So it kind of depends on your burning desire whether you need to ask that question at that time or not. So feel free to interrupt. We can make this interactive, but we can kind of go either way. So we'll see how it goes. So I'm going to start off with a little bit about what is scientific visualization. And if anybody's ever seen me give a talk on visualization before, I almost always start a talk with this quote. This is a quote made by Richard Hamming in 1962. And he basically makes the point that the purpose of computing and what kind of we do as researchers that use computing is to gain insight. It's not about the numbers and the computations that we produce through our research. And what I'd like to argue and kind of present to this group is basically that visualization, which is the process of mapping data into images, is one of the best ways to provide information to researchers about the complex data that they're looking at. We've all heard the phrase "picture's worth 1,000 words." We understand visual information much better than we do just looking at a raw bunch of numbers. So the goal here for visualization is to help get from raw data and raw numbers to insight. And I think we'll all probably agree that the amount of data that we're dealing with has increased dramatically over the last 5 to 10 years. And so visualization is becoming a pretty important tool for helping researchers understand data. This is a visualization that Chris Want at the University of A did in collaboration with Jan Perel at the University of Alberta. And you can look at that image and you can see that there's an enormous amount of data represented in that image, and being able to understand what's going on in terms of the scientific complexity of what's going on in those simulations and the observations that are being made, it's very difficult. So visualization is a really powerful tool to help you understand the information and data that you're looking at and dealing with as a researcher. So one of the questions I want to try to answer at the end of this talk is how can WestGrid help? And what you might want to be able to do with your data and your visualizations kind of moving forward within WestGrid. Some of you may already do this. One question you might ask yourself as a researcher is, should I be using visualization in my research? And I would argue that you probably do. If you're dealing with scientific data, you already do some sort of scientific visualization. Very few people, researchers, look at raw numbers. You might graph stuff, you might stick some data in an Excel spreadsheet and make a graph of it. Those are all visualizations of your data. So really the question that we should be trying to answer here is not should I use visualization in my research, but how can you be more effective in using that visualization? And the kind of issues that I'm going to try to address in this talk is things like how can I get more timely analysis of my data? And really what I'm going to talk about is how can you view data from the clusters that run within WestGrid themselves. So you don't have to copy data back and forth between the cluster and your workstation and things like that. So kind of make that workflow from a researcher perspective a little bit more fluid. How can I do more sophisticated analysis and exploration of data? So I'm going to talk a little bit about some of the tools that we have within WestGrid. That's software tools and kind of the hardware resources that you might want to use from a visualization perspective. And really, how can you have an ability to understand and explore larger data sets? So many of you probably are looking at very, very large data sets. There are tools within WestGrid, including GPUs, so graphics processing units. Basically, graphics cards that exist on your desktop machines, but in particular on WestGrid resources as well. I'm going to talk a little bit about that. WestGrid has specialized displays at some institutes. I'm going to talk a little bit more about that. And I'm going to talk briefly about visualization tools from a software perspective. I'm not going to go into any detail whatsoever about talking about software, using software for visualization. We have some material that we have online that talks about using visualization tools. WestGrid gives workshops on using visualization. So if people are interested in that, I would recommend you contact support at WestGrid or myself, and we can talk about getting into more detail about using specific software visualization tools and things like that. I'm not going to talk about that in this seminar today. So what I'm going to basically talk about are four things. I'm going to talk about visualizing data on the HPC resources within WestGrid, so what I term a quick and dirty visualization of your results. This can give you a quick look at some data and help your workflow be more effective, but it's not going to allow you to do the really complex and sophisticated visualizations. I'm going to talk about using the remote visualization resources that WestGrid has. WestGrid has a GPU cluster. You may or may not know about this. It's Parallel at the University of Calgary. And there are a couple of nodes set aside for doing interactive use of GPUs on that cluster, and we can use those for the visualization of large and complex data sets. I'm going to talk about visualization systems at WestGrid institutions. So WestGrid has purchased some displays and visualization computers that are located in labs at some of the WestGrid institutions, and those are available for WestGrid researchers to use as well. And last but not least, I'm going to briefly mention and talk about the support that is available within WestGrid for your visualization needs. So there are people available that know visualization tools that can help. So if you have questions about using visualization, please don't be afraid to ask those questions on the support@westgrid.ca email list. So the first thing I'm going to mention, we see questions about this fairly regularly on the support mailing list in WestGrid, is really how can I do a quick and dirty, what I call a quick and dirty visualization of a relatively simple data set. So across most of the WestGrid machines, we have a relatively consistent software stack for doing visualization and graphing and things like that. If you go to the software page on WestGrid, on the WestGrid website, I can show you that a little bit later if you're interested. There is a fairly extensive list of the software that's available on WestGrid resources. And among those software packages, there are a bunch of graphing packages and visualization tools. So which visualization tools are installed on which machines? That is relatively consistent across all machines. Some machines have more and some machines have less. Like usual, if you need some software for doing some visualization, please send an email to support@WestGrid. And we'll try to get that installed on the machine you're interested in. In terms of the process for connecting to a remote visualization, the process is actually pretty simple for a kind of quick and dirty, and I'm going to try to walk through this really quickly, so hopefully that'll work for us in a live demonstration. But basically the process is you create an SSH tunnel to the cluster that you're using, whether that be Bugaboo or parallel.westgrid.ca or whatever. You forward the X traffic, start up an X server on your local machine, and run an application. This can be done very, very easily. You don't have to have a lot of experience, and you don't have to do very much to make this work. The pros of this, of course, is that you don't need to move the data back to your home workstation. You can basically do a quick visualization of the data that's being produced by your computational simulation. And it works well for simple visualizations that don't have little interaction or little exploration. So if you're not doing very much, but you want to look at data really quickly, you can do that quite easily. The cons of this approach basically are that it's relatively low performance. So if you're connecting to parallel.westgrid.ca, which is a U of C machine, University of Calgary, from SFU, if you're doing it via X windows, if you're trying to do something that is interactive, you're trying to explore some data, it can be quite cumbersome, and so you may not get the performance that you want. So it's not great for exploratory work. And some of the more visualization software packages that use or require GPUs and things like that may not work very well on that through the X Windows interaction layer. So there's a couple of cons there that you should be aware of. But it is a pretty powerful way of getting a quick and easy look at data on the cluster without having to copy data back and forth. So the process, as I said, is basically SSH with X11 tunneling. There's a simple command here that you can see up at the top. Basically, it says SSH to bugaboo.westgrid.ca with the X forwarding. You need a terminal client on your machine on OS X or Windows. You need to start up an X server locally. You can use something like such as Cygwin or Xming on Windows. OS X typically comes with X11. And basically, you just simply have to run the X application on the head node of the machine that you're using. I'll quickly show this. Really quickly. So if this all works, of course. So can people see this? I think you should be able to see this okay. When I was testing this earlier, this worked fairly well. So this is basically a terminal client on my on the Mac workstation that I'm on right here at SFU. I am actually, oops, sorry, I'm already logged in, so let me log out. So I'm on a local machine here. All I'm going to do is I'm going to SSH to parallel.westgrid.ca, and I've got this -X command line flag. I basically do that, and type in my password, and then I can run interactive applications like NEdit if I want to edit a file on this machine, or I can run GNU plot. And if I plot a function, it appears on my desktop. So basically, this is running an application that is plotting a data set on parallel.westgrid.ca at Calgary. It's pretty straightforward. It's pretty easy to do. The only thing that you have to do really is create an X server on your machine. On OS X, that actually comes with the operating system. So you just have to actually specify the you basically just have to specify the -X option, and away you go.
Is it possible to make that font bigger?
I might be able to. Oh. So all of this is in the PowerPoint presentation. All of this is also documented on the WestGrid website. So if you are missing some of the minor details of this, please refer to both of those. The details are actually in the presentation as well. So I can talk about that in a little more detail about how to set that up. It's relatively straightforward, and it's good for if you want to edit a configuration file that you're submitting a job for, if you want to look at a data set that is not too large or not too sophisticated, or you don't need interaction. Running applications like ParaView or VMD, which are kind of more sophisticated visualization applications, that might be a little more cumbersome and a little more slow. Sometimes they won't work because they use some of the more advanced features of a GPU, and sometimes the X Windows protocol doesn't support that very well. So you have to be a little bit careful, and your mileage may vary in terms of how effective those kind of applications are. So the other kind of key way of doing visualization on WestGrid resources is using parallel.westgrid.ca. So Parallel is a large cluster at the University of Calgary, and it has a number of specialized nodes, 60 of them, that have 3 GPUs or graphics cards, basically, on each of those nodes. So there's 180 GPUs. For those that are interested, they're NVIDIA Tesla M2070s, et cetera, et cetera. These nodes are targeted for mixed usage, primarily for GPU computation. But we have currently 2 nodes set aside for 6 GPUs that are available through an interactive queue on parallel.westgrid.ca. So you can submit an interactive job, connect to a GPU remotely to Parallel, and connect that to your local desktop. So your data is basically staying on the HPC resource while your visualization is being displayed on kind of the local machine. So this is beneficial if you have a need for using advanced hardware for visualizing very large data sets. So the GPUs on Parallel are quite powerful. So if you have thousands or millions of polygons, very large data sets that you need to look at, that is going to be very difficult to do through the X windows, the previous technique that I talked about. It's even going to be difficult to do if you copy the data to your local machine unless you have a good graphics card in your local machine. In addition, there's some advanced software installed on on Parallel. 2 packages in particular that I recommend people consider if they're doing visualization are ParaView and VTK. And we have a new software package that we're in the process of installing right now called the Viso, which is a commercial visualization package that's also quite powerful. And one of the nice things about using Parallel for visualization, if you want, is that it provides you with fast data transfer from other Westgrid hosts. So if you're doing a computation on Bugaboo and you want to transfer a fairly large data file, that transfer will probably be faster to copy it from Bugaboo to Parallel than it would be to copy it to your local workstation or your home computer or something like that. Remote visualization on Parallel works fairly well, even from the home. I'm going to demonstrate that in a minute from the facility here at SFU, but I've done it with a remote desktop client on my iPad. I've done it on my laptop from home over wireless. It actually is quite functional from even relatively low network connection. So you can be visualizing a very, very large data set on the HPC cluster and displaying that on a local machine that actually doesn't have much capability, right? So you don't have to go through the pain of installing software on your workstation. You don't have to have a graphics card capable of doing the visualization that you need, etc. All of that is on the GPU cluster. I don't want to scare you, but the process for doing this is a little more involved. But I'm actually going to do it. So it's actually quite similar to what we did with the X windows. There's a couple more steps involved. But basically what you do is you start a server on the GPU cluster, you start a client on your local workstation, and you connect the two together and run a visualization. There is a special software package called Turbo VNC that you need to install on your local workstation. You do have to use QSub to create an interactive job to acquire a node with the GPU attached. In my experience, that usually happens within seconds. So you don't typically wait in a batch queue for interactive jobs to run. They actually run very, very quickly. I'll hopefully demonstrate that. And you have to set up some SSH tunneling that I'm not going to go into too much detail, but it is documented on the website, and we can talk about it if you have questions. The advantage of using this technique rather than X windows are twofold. First of all, the VNC server, which allows you to create the connection to the GPU, is optimized to make use of the GPUs. When you use an X windows connection, typically that is not very heavily optimized to use the graphics card to do the visualization. So the Turbo VNC server that you run on Parallel is actually optimized to make excessive use of the GPUs. So any visualization package that you run on Parallel is going to run very, very fast on the graphics cards that are available, which are very, very powerful. The other thing is the client and the server, the client that you run on your desktop and the server are optimized to transmit the pixels of the desktop that you create on the remote visualization machine very, very effectively and efficiently as well. So you're able to run relatively high quality visualizations over wireless networks and things like that. So again, it's a very, very effective way of doing a very, very sophisticated visualization with kind of a low-end client. Again, as I said, even down to my iPad if you're so inclined. So I am going to run through this process again. So I'm going to do a couple of things. I'm going to SSH to parallel.westgrid.ca. I hope you can see that now. Actually, maybe I'll try to blow this up a bit more. So all I'm doing is I'm SSHing to parallel.westgrid.ca, and I'm creating a port forward on port 5901 to a node which is CN0553. So CN0553 is actually the node that I'm going to connect to on the actual with the actual GPU attached. So that's basically like any other SSH. I'm going to do a queue sub to the interactive queue, asking for one node, one processor, and one GPU, and a wall time of an hour. Now, with a little luck, this is going to start in a couple seconds. And it did. So now you can see I am on node CN0553, and if you'll recall, that's the node that I put in my port forwarding. I need to start the VNC server on this machine, and I'm going to use a geometry of 1024 by 768 pixels because that's how big my desktop is on this Mac that I'm using to share this presentation with you. And it tells me that I'm connected on X window display :1. So that's an X Windows kind of protocol thing. That actually maps to, let me blow this up. That actually maps to this :1 that you see here that I'm creating with my VNC viewer. I start that up. I have to type in a local password that I created for VNC. This is going over the SSH tunnel, so it is actually secure. And what that gives me is this is an X Windows desktop on parallel on the graphics node with the GPU attached to it. Okay, so I'm running an X, basically a Linux X desktop on a parallel node right now. I can start up my client. I'm going to run an application called ParaView. You can see the path here. One of the things that you have to do is you have to use a command called VGL run. That will enable that application to run with the optimized GPU software stack. If you don't use that, then you're not going to get the optimized software stack, and you're going to not get the performance of the OpenGL graphics card that you're running. So I'm running ParaView, and I am using a data set from a researcher that I've been working with doing some visualization here at SFU. I start up ParaView, and I am running the application remotely on the GPUs, on the graphics card, on parallel, and it's sending the pixels to me here at SFU, and then I'm sending all of those pixels to you at each of your sites through the video conferencing unit. So there's a lot of places where latency could be introduced into this, but as you can tell, the interaction is quite fast. For people here at SFU, it's almost like I'm using this on my desktop. This is an animation of a cell biology data set. So I'm stepping through the time frames over time. So this is a relatively sophisticated visualization of a relatively complex cell biology simulation. And I'm able to do this with relative ease from the perspective of the commands I issued to make this connection and a very high level of efficiency in terms of my interaction. If I stop the animation, I can kind of show you the number of triangles that are in this data set. It's not huge, but oops, didn't want that. I want to go here, and I want to show surface with edges. So there you can see the number of triangles that are in this data set. I don't know how many there are. There's probably several hundred, I don't know, 100,000? 151,000 triangles in this. So it's not a huge data set from a polygon perspective, but this would perform very, very well if I had 500,000 or a million triangles because I'm using the GPU on parallel, and so I'm able to visualize a very, very large data set very effectively without having to have any hardware on my desktop, basically. So what I'll do is I'll just quit ParaView. I'm going to quit my desktop. I'm going to kill off my server that I started on the node. I'm going to log out from the node I got, the interactive node on Parallel, and I'm going to log out from Parallel. So basically that's the entire process of doing a relatively sophisticated visualization using the GPU cluster at the University of Calgary. So that allows me to do visualizations that would be very, very difficult for me to do unless I had a very sophisticated hardware setup in my office or in my lab for my research group. So that's the goal for kind of a remote visualization from a parallel.sfu or parallel.westgrid.ca, right? So it's basically allows you to do very sophisticated visualizations relatively easily without any local hardware. And as I said, you can do these kind of things at home. It's a little bit more clunky in terms of the interaction, but it actually can work quite well. So this was my backup slides in case none of those connections worked. So I'm just going to skip through these. So again, these slides will be available online if you want to have a look at them. And again, they are documented on the WestGrid support website as well. Most of that documentation is fairly well done on the remote visualization page on the WestGrid site. So another thing that researchers should be aware of in terms of the capabilities that WestGrid has, in addition to kind of the GPU resources and the visualization software that exists on the clusters themselves, a number of institutions, not all of the institutions within WestGrid, but a number of the institutions have purchased visualization-capable systems that exist in labs at your local institutions. These might include advanced displays, either high-res or 3D displays, high-end visualization computers with fairly advanced GPUs, a fair bit of memory and a fair bit of disk, visualization software, and typically that visualization software is customized to work with the displays. And in addition, WestGrid has purchased those equipment to go in those facilities. So those kinds of facilities work at SFU, exist at SFU, University of Calgary, University of Alberta, University of Saskatchewan, and University of Lethbridge. WestGrid has also partnered with a couple of other labs, in particular ERMAX at SFU and the Advanced Man-Machine Interface Lab at the University of Alberta to purchase hardware that exists in those labs. So these facilities are available for you as researchers to use. They are available and supported via the WestGrid support team. So if you are interested in using these facilities at these local, institutions, please send an email to support@westgrid.ca and or go to the support visualization facilities page on the WestGrid website. Here's just a couple of pictures of the types of hardware that's available. On the left, you'll see a system, what we call the IQ Station. These systems are available at SFU, U of C, and U of A. They are relatively portable in the sense that they're on basically a stand and can be wheeled from lab to lab. And I think each of the institutions, SFU, U of A, and U of C, are quite willing to have these systems loaned out to labs if you have some visualization work that you want to try. So if you are interested in using these facilities or these capabilities, they are typically 3D display systems, so they're 3D plasma TVs with a fairly high-end graphics card, visualization computer with a high-end graphics card attached to them. So you can either come to the facilities at the institution or actually possibly borrow them and have them in your labs if you're interested in doing that kind of work. On the right-hand side is a 3D visualization display capability that we have here at the ERMAC Center theater, and so this facility is basically targeted at people who want to do presentations that have a 3D component in their visualizations. So there are similar facilities at U of C, U of A, University of Lethbridge, and USask. There are probably others that I'm missing. So these are available. Please send emails to support at WestGrid if you're interested in using these. And last but not least, there is a fair bit of expertise within WestGrid that can help you use visualization tools and the visualization hardware that is available across WestGrid. So we can give you support in using WestGrid equipment, the clusters, and the Viz facilities. And we can help you do visualization using visualization tools in your labs after you move your data if you need help. I would say if you do have questions or want to be able to use visualization more effectively, please don't be afraid to ask for help. Send an email to support at WestGrid. That is your friend in terms of all things WestGrid. And if you have questions about visualizations, please follow up on that email list, and or go to the visualization support page. That is where you'll find basically a deeper representation probably than I've been able to present here in terms of using the facilities. So that is about all for my formal presentation. So we have about 25 minutes to talk amongst ourselves. So I think we'll just open it up for questions. And so if you could just kind of let your site, the person who's in charge of your site, know if you have a question, and go ahead and ask away, and we'll see if we can answer. So are there any questions here? SFU side first. Okay. No questions? Did I bamboozle you with too much information?
We've got a question here at UBCO.
Yep.
Sorry, I have a question actually. So this facilities is just for visualization, yeah? It's not like for running codes. So anyone want to use it, just have the data available and then send it to this facility so that then get the visualization of the data, or just it's like someone write a code and then run it and that out on those facilities, and then, you know what I mean? Because, it will be really huge data if you want to just send it to that.
The facilities on the WestGrid, like the GPU cluster, for example, are targeted for you to do visualization of your data. So if you have a data set that you would like to visualize, we can help in a number of ways. We can help you use the visualization resources within WestGrid, the GPU cluster, parallel.westgrid.ca. We can help you use visualization software packages more effectively to help you visualize your data. And we can help you do that either using parallel or local resources at your institution. Did that answer your question?
I think he was wondering about the computation side.
Yeah.
Can you to produce the data on WestGrid also?
Yeah.
I mean, absolutely. I mean, WestGrid, I think, is typically used to produce enormous amounts of data. And so running your simulations on WestGrid resources are absolutely what the WestGrid resources are targeted at. Certainly my talk is mostly about, once you've done that, how do you visualize them effectively once you've got data on a WestGrid resource already? So if you need computation to generate or process data and or simulate and generate data, WestGrid is an excellent resource for that. Definitely.
Oh, okay. So just a quick question. What kind of code, formats do they support? Do they support Fortran codes or just C codes, or do you know what I mean? Visual Basic?
And anything that runs under Linux will run so C and Fortran code, if you have C and Fortran code, it runs on Linux, yes. Absolutely.
Yep, nice. Thank you.
No Windows.
Oh, okay.
There's a question here in Calgary.
Yeah, go ahead. You're a little bit quiet, so speak up.
Yeah, so the example that you showed earlier with the simulation, I was wondering what sort of frame rate should we be expecting for that? So that was like around 150,000 triangles. What kind of frame rates should we be expecting if we're doing this using remote visualization, just so we know that we're getting the optimized performance?
I mean, off the top of my head, I would say that I was probably seeing 12 and 20 frames per second. That is actually, so there are two limitations when you're doing a visualization. One is how much data you have and how much the GPU can handle. The GPUs on Parallel are very powerful, so they can handle a lot of triangles. So if I increased the number of triangles from that 100,000 that I had to 1 million, the GPUs on Parallel can probably handle 1 million triangles at 12 frames a second, so I wouldn't see much difference in terms of performance. If you start to push the limits of the GPU, you will start to see a performance degradation of your visualization. You would have that same performance degradation if you're doing that visualization locally on the same GPU in your workstation. The performance degradation that you would see from the remote visualization part is really limited by the bandwidth that you have between the local machine and parallel.westgrid.ca. If that's a good connection, then you're going to get very interactive rates, much like I was. This was really interacting for me. I'm not sure how it came across at University of Calgary, but for me, it's like I'm running that application on my desktop for the most part. I had very little latency in my mouse clicks and things like that, so it was very, very interactive. If I was to do that at home on my over my wireless home network, going over my SHA connection to parallel.westgrid.ca, I'm probably going to maybe get 7 or 8 frames a second or maybe less. So it kind of depends on your network connectivity for the remote part and what the GPU limitations and the size of your data set for the graphics part. And those are the two pieces that are going to kind of dictate where you see interactive frame rates. My experience is that it's pretty good, and if you're willing to compromise in the quality of the remote visualization, the nice thing about the remote visualization application is it compresses the images quite dramatically that it sends to the remote site. So if you use a higher compression, then you can do more over a smaller bandwidth connection. So you might get some pixelization and compression artifacts in the visualization, but you'll still have the interactivity. So there's a trade-off there that you can do as well.
Is there any question from you?
The question
One
from
question
Vic?
from you, Vic.
Go ahead.
You've been logging in on diverse computers remotely using SSH,
Yeah.
using accounts. So these accounts are they the accounts that you've been granted after you've been successful with the resource allocation committee proposal? In other words, for visualization, in other words, do you need to go through the rack to get time?
No. So any faculty member can get a Compute Canada/Westgrid account for no cost, and then they can sponsor any student account to get access that they supervise, again, for no cost. You do not need a resource allocation for that, and that will get you access to using the all of the Westgrid resources, except with the exception of a couple of specialized systems. If you want to use the Parallel GPUs, can somebody at U of C remind me, do you need to make a special request to get access to Parallel? I think you do. But that is not tied to a rack allocation. That is tied to a need to use the GPUs. So you need to send an email to support at Westgrid saying, I would like to use parallel.westgrid.ca. I need to use the GPUs for remote visualization. And they will enable your account on Parallel for use of the GPUs. Again, that does not require a rack allocation. If you need to use a lot of GPUs, or if the interactive nodes become very busy because everybody's doing remote visualization, then we will start to get into some resource contention and things like that. But thus far, that has not been a problem. So you basically don't need a resource allocation. You don't need to worry about, the only thing you'll have to do is ask for an account on Parallel through the support email list to get access.
All right, thank you.
Are there any other questions?
One here.
Yep.
Is it possible to record your session such that you can get a high frame rate? So if you interactively you're only getting 12, but you want a 24, you want a 30 frame for basically a demo. Is there a way to basically render that into a file and then download it?
Yeah, there are a couple of ways of doing that. I mean, if you wanted an interactive session and you were troubled by getting only 15 frames a second, you could do a couple things. You could increase the level of compression that's used. So you might see a bit of compression artifacts in kind of color space, for example. But that would give you probably 24 or 30 frames a second. It would be very interactive. If you wanted to record a visualization, several of the software packages, ParaView in particular, you can record the output of that visualization I was doing to an AVI file or an MPEG file or something like that. So you can do things that way as well. There is no real way, as far as I'm aware, with Turbo VNC to record a session that I'm aware of. There might be. I'm not 100% sure. Sorry, did you have a follow-on there? I think your mic might have been muted.
Thank you. Oh, just thank you.
Okay. Any other questions?
I have one for you, Brian. So does the
Yep.
like the two GPUs that we have, are they being used by ParaView when you run one, or can you launch two at the same time and one will be using or both, or what? How it's configured right now?
Yeah, absolutely you can. If you want to use some packages like VMD, for example, can use multiple GPUs. So if you schedule, when I did that Q sub for the interactive queue, I only asked for one node, one processor, and one GPU. If you ask for 2 GPUs or 3 GPUs, you could tell VMD to run on all 3 GPUs if you wanted to. If you wanted to use one GPU for computation and one GPU for visualization at the same time or something like that, you could do that as well. All right. Any other questions? Okay, so thanks everyone for coming. So as I said, there's a WestGrid representative in each of your rooms, I believe, so they can answer questions further. We have 2 more talks in this seminar series. I think the next one is a research-focused talk on multiphysics codes, and the final talk for this semester is a MATLAB, using MATLAB and WestGrid talk. So I look forward to seeing you at those talks, and thanks for coming.